Hello, and let's get started with Palladio. So what we're going to be doing here is we're going to be looking at how to create data that is useful and good for Palladio, and then we're going to be looking at how to take that data and import it into Palladio and map it and graph it in Palladio really quickly and very easily. So let's go ahead and just jump right in. We're going to click start on the main page, and we're going to be working with this try sample data. And once you download it, you don't have to, but it's nice to download it. You're going to be able to see what this sample data looks like. I recommend opening it up in Excel. Excel allows for you to look at the data very easily in a familiar environment with rows and columns. Now you've got two different Excel files here. You've got one labeled people, and people has a few different columns. They've got birthplace, arrival point, birth date, gender, position, place of death, date of death, pick. We'll talk about that in a little bit. We've got site and primary. Throughout this tutorial, we're going to be really focusing, especially early on, in a lot of this nominal, so names, and geospatial data. We're going to be looking at birth date, and we're going to be looking at things like picture a little bit later. But what we're very concerned about for these initial discussions is going to be name and place, whether that's birthplace, arrival point, or place of death. The other file that you have here is an Excel file. It's actually a CSV file, and it's called place. And place has two columns: place, which is a place name, and coordinates. What Palladio is going to do is it's going to use both of these CSV files in tandem so that it can take any place cited in this Excel spreadsheet or CSV file and automatically assign the correct coordinates to it: latitude, comma, longitude. And that's going to allow for Palladio to map out geospatially any place that is referenced in the main CSV file. Before we get into that, though, let's talk a little bit about CSV files. So, what are CSV files? Well, CSV files stand for comma separated value files. And what that means is that this entire file right here isn't actually an Excel spreadsheet. What it is it's a file that has name, comma, birthplace, comma, arrival point, comma, etc. And then the same thing happens for this row here: Sarah Murphy, comma, Cincinnati, comma, Monaco, comma, etc. This is what comma separated values means. It means rows and columns that are separated by nothing more than commas. If you're going to be creating your own data set, I recommend that you work within Excel because you can easily create CSV files. Once you have your data set up the way you want to see it in Excel, go over here to click Save As, and then just choose More Options and select CSV. I recommend using CSV UTF-8, which is going to put your CSV file and force it into UTF-8 encoding. The other option is just to use CSV. Either way, you're going to have kind of the same result. So let's go back to our Excel file here, see what our stuff actually looks like. So we've got all of this information. That's what we're going to be working with. Once you got the data created, you don't really need to do anything with it in Excel anymore. All you have to do is import it into Palladio. And because we're kind of working with the sample data provided, we don't really have to do much more than that. So let's go ahead and go back. Let's hit start, try with sample data, and then we're going to go ahead and just kind of jump right in. So we want to map out this data. So we can click on map. Before we jump in and start talking about Palladio, there's really two key terms that you must be familiar with. That is node and edge. We're going to talk about some other key terms like source and target naturally as we kind of progress through this video. But what is a node and what is an edge? Well, a node is any dot on a network graph, either a geospatial network graph or a social network graph, any kind of graph. A dot is a node. An edge is a line connecting two nodes. So a dot is a node, an edge is a line that connects two nodes. That's all you have to know to kind of move forward. Those two basic concepts, but very fundamental ones. So let's jump right in with mapping our data. Now, this is what the mapping default looks like. It's a grayscale image of the world with dark gray rendering as water and light gray being your land. Now, fortunately with Palladio, you're not limited to just this main template. This is where we're going to be plotting all of our data. We can actually create a new layer. If we click over here on the new layer button, click over here on tiles. Now, as we can see from tiles, we've got a few different options. We can use what we see here as just a standard land one. We can see building areas, streets, terrain, satellite, and we can even import a custom tile, which is going to put a custom map or whatever we want to see as our background. Let's check out building areas and that. We can add that layer, and now you can see our map has changed somewhat. When we zoom in, we can start to see that it looks more like a real looking map of the world. It's a little longer to load. So that's the big caveat here. You get more detail, more nuance, but that comes at a cost of speed. Now we can also erase that layer, zoom back out so you can see what I'm looking at. Oh, it helps if you have it loaded up. There you go. And you can alternate between different layers. You can switch different layers around. So you can put the building areas beneath that, and you can close that, and now there you go. You can add a new layer. We can add a satellite image view. Let's drop that in and delete those. There we go. And you can see a satellite image view of the world. All of this is going to allow for you to have really kind of the ideal map that you want to see from your point of view. So let's go ahead and just work for speed's sake with just the standard land. I'm going to go ahead and delete these with the garbage button. Now, what I'm going to do here is start to map out our network geospatially. I can do that by clicking New Layer. Now, instead of playing with tiles or shapes, I'm going to go to Data. Now, in Data, I have a couple different options here. I can input a name for the layer. I can input a map type. I can input places. This is going to be the places that I want to plot. I can input a tool type label. This is going to tell me if I want to use coordinates or place. And then I can also choose a color and size point. And this allows me to actually affect the size of a plot based on number of connections that I set, either if it's to people or in this case places. We're going to ignore that for right now. So let's look at this first layer. I'm going to select birthplace, and I'm going to just simply say birthplace for a name here. And when I hit add layer, you'll see I automatically have all of these dots. When I zoom in, you see that the dots actually have a name, and that's going to be the places that are geospatially mapped. What we don't see here, because it's just geospatial data, is what these dots specifically correspond to, meaning we don't really see to whom they correspond. We just see Glacia, and that's it. What this is doing is it's showing us a couple pieces of very important information. It's showing us a place, and then we see that that parentheses is also there. That's indicating the quantity of people associated with that place. Now, we don't see qualitatively who they are. Let's edit this, and we can change this now a little bit. We can change the color. Let's make it red. And now we see all of our dots are red. We can also change the size. We can change the size based on two pieces of information: number of places, number of people. I'm going to change it to number of places. And now what you're seeing is Paris having a larger node than St. Cloud, because Paris has 21 people who were born there in our data set, while St. Cloud has only one. Now, as this is a Monaco-centric data set, it makes sense that we're seeing a lot more of Europe activated as opposed to places like the US or Asia or Africa or South America. So when we zoom in, we can see immediately some interesting results based on our data set with nothing more than simply 1 point plotted. What's really amazing about Palladio is it's not just a way to map out data geospatially. We can also map things out by looking at network graphs more dynamically and with more nuance. So if we select point to point, we can select two different pieces of information to map. We can select a source place, which is going to be, let's stick with birthplace. and we can select the target place, which is going to be the place to which a line is drawn. So this is going to be the source from birthplace, so from France, to, let's say, place of death. We'll be able to see how individuals migrate from where they're born to where they die. And we hit apply, and we can immediately see a lot of really kind of interesting results here. We can see that while there were 21 people connected to Paris, France before with place of birth, we now see that that number has increased to 36, which means we're seeing a lot of people added to that data because they died in Paris, France. And if we look under here, we also see these lines going from one place to another. This is indicating our source to target, and this is called an edge in a network graph. And what we can do in Palladio is put our mouse over the edge, and if we're very careful, we can see, let me try to line it up. There we are. We can see what's happening. We see one person going from Philadelphia to Monaco. Now, that's the basics of how to actually geospatially map out data. But one of the limitations here that we don't see is we're not seeing anything with regards to social networks. We don't know who these people are. We just know that there are a certain quantity of people that are making these movements. Let's move on to graph then, to start graphing out the individuals behind these geospatial representations of the data. So let's graph our data by clicking the graph option up here. Now notice that our map has gone away. Don't worry about that for right now. Let's talk about the social networks in our data set. So we can customize our social network graph by creating a source and a target. Once again, just like with the geospatial data, our source is going to be the node that is inflicting force upon the target. So imagine a line being drawn from a source to a target. So we've got a couple different options we can pick from here. We can select arrival point, gender, name, birthplace. We've kind of seen some of that geospatial network. Let's work with some more nominal data, so names. So we're going to choose name as our source, and we're specifically interested in, let's say we're interested in where people are born. So we can actually map out geospatially individuals and their birthplaces. And what we have here is almost instantaneously a graph created for us. Now, we see just a very plain kind of normal graph. Not a lot is happening here with regards to flare and color. We can change that though. But what we have here is data being represented visually, and it's already very clear that we're seeing patterns in our data that might not be immediately clear if you're just looking at the data like this. Like, here's our data. If you wanted to identify how individuals overlapped with regards to birthplace, it would take a while to kind of sit here and sort through all these birthplaces and names, and we're only dealing with a data set of 74. Imagine if you had a real world data set, which is going to be in the thousands most of the time. You can see very quickly how being able to render that data visually is a lot easier to identify significant patterns. So were I to look at this data, I can immediately see that Paris is a cluster of high activity. So what is a cluster? A cluster is a concentration of nodes in a network graph. What determines a cluster's size, or what pushes something into being labeled a cluster, is really dependent upon your data. If you have data that has, let's say, 8 connections is really common, then a cluster is probably going to be something with 20 or so. It's really going to be relative to your data. If we jump in, though, we can see that certain things are unique. For example, we only have one individual who is associated with Mugla as a birthplace. That's kind of interesting. Let's see what else we can do here, though. We can go here and we can select highlight, which is going to highlight the source. We can select highlight, which is going to highlight the target, which makes our separation of this data a little easier to identify. We can also change the size of the nodes, and just like the geospatial data, we can change this according to number of people or number of places, which means we can kind of reverse this graph around a little bit. Now, if you noticed what's happening here, when I switch between these two, the graph kind of goes a little haywire and moves around and changes. What is happening here? We don't really need to know this as humanists, but what's happening here is a graph is basically a visual representation of mathematics. What is happening in the background is an algorithm is determining the placement of these nodes on this graph. And anytime you alter the data visual rendering, it's going to radically change where nodes appear on a graph. Also, you can drag nodes around in Palladio and move them to where you want to see them. This is known as a dynamic graph, a dynamic social network map. And it really lets you take screenshots and kind of customize a graph to really render how you want to see it. Let's talk about how to represent our data in Palladio so we don't have to keep on going back to Excel to reference it. The way in which we're going to do that is with the table button up here. Now this is going to allow us to have two different options here, row dimensions and dimensions. Let's start here with dimensions. These are going to be the things that we want to see rendered on our data set. So we can select everything, and you'll see what this will do in just a second. We close, and then we have it all structured by name. And this is going to allow us to actually render our whole data set however we need to look at it for any kind of observations we want to see. So we can get rid of everything except for just, let's just do this. Let's get rid of all this stuff. And we can just simply look at the geospatial data that we care about. So we've got name, place of birth, and we can kind of minimize that, birth date, birthplace, place of death, etc. So we've got a lot of really important information rendered here on this graph, or this table very quickly and very dynamically. And in some ways, it's a little more easy to work with if you have a whole bunch of dimensions or columns in your data set. If we want to get a sense of the images that are associated with our data set, we can go over here to Gallery, and you'll notice that you already have some of this stuff loaded by default. And that's because we had images in our data set. So how do we actually get this to display the images? Well, let's go through and do a few things first. Let's look over here at our Settings tab. We've got title, subtitle, text, link, image URL, sort by. So right now, let's just leave it as is. We've got name associated with name, seems logical, and that's what's displayed up here. Subtitle, we can have anything from birth date to birthplace. Let's select birthplace. And we see that that gray text is now the birthplace of the individual. And for text, we can say something like, I don't know, let's say place of death. And now we can see two key pieces of information. Now, in other data sets, this might be more useful if you have like a brief biography of the individuals in your data set. So let's skip link for right now, and let's click image URL, and this is going to allow us to populate pic. Now, what is pic? Well, let's look back at our data set. Pic, if we scroll up, is this column right here, which is all of the data associated with images. And if you notice, these are all the URLs so that Palladio knows where to go to get the pic. And what it's doing is it's dynamically loading in all of these URLs in the background and then populating them on your page, at least for the ones that it knows, for which ones it actually has URLs for. And then we can also choose this sort by. So we can sort by name, and we can kind of select that. Let's change our subtitle to, let's change our text actually to position. This will tell you what the person's job was, so we can change everything by position. Oops, there we are. And you can kind of organize all the aristocrats together. This allows for you to easily go through and look at your data as it's rendered visually. So, visually in the sense of images associated with them. So that's how the gallery option works in Palladio. Very useful, very nice feature. One final thing I want to talk about, and that is what's going down here and the bottom tab. Well, down here we have some temporal layers that we can add to our data. And if you click time span or timeline, you can see different renderings of these same data. What you are seeing is your data represented chronologically as well as geospatially. So we have a timeline here that allows you to see individuals and their birth and death, and you can actually highlight the different sections. If you look at the graph up above, you can see the graph kind of come to life. You can highlight, let's say you just want to grab the individuals from the 20th century, so 1900 to 2000. You can do that by just selecting it like that, dropping this down, and now you're only seeing the data associated with that particular time frame. You've successfully filtered your data. That's the technical term. And that's what this filter down here, this chronological filter, allows for you to do. This is an incredible feature. As somebody who has to typically program to get specific results for social network graphs, chronology or rendering data temporally is one of the biggest challenges. In R, if you program in R, you've got NDTV. If you're programming in Python, though, you have to get kind of creative in how you do this. There are some ways to do it, but I can tell you right now that this chronological feature is probably the most useful thing about Palladio from a network mapping point of view. It's incredibly simple to use, incredibly simple to start looking at your data visually with that filter of chronology. I absolutely love it. So overall, this video has kind of gone through what CSV files are, how to load them into Palladio, how to work with them outside of Palladio, how to map that data geospatially, and how to map that data with regards to social networks or typical mathematically represented graph by having a source. We used name and what target. I believe we used the birth place of death or birthplace. And what this allows for you to kind of do is to immediately see some really interesting and significant things about your data that might not immediately be clear. And if you notice on this network graph now, we're not seeing pairs as active. And that's because we have that chronological or temporal filter. If we get rid of it, it goes back to normal. That's the power of Palladio, the ability to quickly render a whole bunch of data visually without any knowledge of computer programming or really the need to learn a whole bunch about a specific tool. It's a quick and easy tool to use. If you've ever worked with Gephi, you know that there is a learning curve for Gephi. With Palladio, you don't have that learning curve. You can just drop your data in and start seeing results within minutes. I highly recommend playing around with it, getting comfortable with it. If you have questions about Palladio, send me a comment down below and I'll try to get back to you as soon as I can. That's all for this video though. Thank you for listening, and if you've enjoyed it, please like and subscribe down below.